If you're sitting in the audience and you expected a presentation on how you could lose 30 pounds this weekend, earn $40 million, and impress the members of the opposite sex, you're in the wrong session.
And I would say if you think the answer is Plan B, you're in the wrong section too.
So no matter what, you're in the wrong section. Okay, why don't we get started here? Okay, the gentleman on my right here is David Keith, and rather than I making an approximation to who he is, I'll let him self-ID. Tell the audience who you are.
Sure. I'm David Keith. I'm a faculty at Harvard in the engineering school and also in Harvard's School of Public Policy, the Kennedy School. And I've worked on climate in some form really my entire career. I think I got interested in 89 or 88 or something. And since about 91, I worked on climate continuously, but a big range from doing real climate science, developing new instruments to measure the planetary temperature, to technology development and a lot of energy policy work, and finally to this work on solar geoengineering that we'll talk about.
And you also have a background in physics, right?
Yep, physicist originally.
Okay, there you go. My name is Seth Shostak. My background is in astronomy, but I'm also the co-host of Big Picture Science, which I commend to all of you. Okay, so David, you've already disclaimed the idea that there's a plan B for climate change. I mean, aside from the obvious approach to getting the climate back under control, you know, making sure that you only drive your SUV downhill or something like that, right? There is the possibility of geoengineering. Give me an example of geoengineering.
So to me, there are, the thing at least I work on is solar geoengineering or solar radiation modification or radiation intervention or whatever you want to call it, but these are all ideas about how humans would deliberately alter the energy balance of the Earth in some way, say by putting reflective aerosols in the atmosphere or a big shield in space that would offset some of the risks of accumulated carbon dioxide. So that, to me, is what solar geoengineering means.
Okay, so what you're saying is the way to avoid the worst effects of climate change is just to block some of the incident solar radiation. Just put up, I don't know, put up little tiles or something in orbit and just block some of the sun.
Well, I said what it was. I didn't say it was a way to block the worst effects. And I think that does get into my reticence to say that it's Plan B, because people have this idea that so you try Plan A, and if it fails, you do Plan B. And I think that is just deeply wrong here in the sense that it's and, not or. We have to cut emissions. In the long run, we have to bring net emissions to zero if we want a stable climate. End of story. It's as simple as that. But we might want to do other things as well, like adaptation and maybe solar geoengineering. But these are not, there's not just two, there's at least four, and it's not one or the other.
Okay, but if you look at the progress that's being made on controlling emissions, I can't say that it's stellar.
Well, whether it's stellar or not, we have to do it, and nothing about solar geoengineering gets you out. So if you're thinking that solar geoengineering is a Plan B because we're failing to cut emissions, then you're doomed. I mean, that just cannot work.
We're doomed. But
Yeah.
have you not?
Well, I don't think we are doomed. I actually think that humans have dealt with environmental problems time and time again. Too late, but we have. We've made progress on all sorts of big things, on metals, on global ozone, on air pollution, on water pollution, and those are true really globally at big costs. And my expectation is we will make progress on cutting emissions. It's slower than we should have, but we can and will bring emissions to zero.
Well,
so I just refuse to buy this idea that somehow we're going to fail.
Okay. Well,
Yeah.
I appreciate your optimism. I mean, would you?
I don't think it's optimism. I think it's based on understanding human self-interest and looking at the history of how we've tackled environmental problems.
Okay.
Yeah.
But would you be willing to characterize these sorts of, if I can call them, geoengineering efforts as something that might be useful in the interim until we get carbon emissions under control?
Not that useful because you forget that the problem isn't daily caused by emissions, it's daily caused by the cumulative amount of emissions, which is concentrations. And so if we just delay, all we do is build up the concentrations more. I really think in some ways these are independent ways to work on the risk. So the longer we delay, the more risk we build up. And solar geoengineering, I think the strongest thing you can say is the combination of emissions cuts and solar geoengineering might be safer than emissions cuts alone.
Okay.
That's a statement I can go behind.
Give me some examples of solar geoengineering that you're investigating? I mean,
So you might take marine clouds, such as we see off the coast of this part of the world, and add sea salt aerosols to them in a way that makes them live a little longer or be a little whiter, and that might cool the planet a little bit, especially locally, and reduce some of these climate changes. You might put aerosols in the stratosphere, or like 15 or 20 kilometers over our heads, where they reflect away some sunlight. There's a range of these ideas.
the aerosols in the atmosphere.
Yep.
I mean, you're talking about, for example, aircraft delivery of, I don't know, things that might reflect some of the incoming sunlight.
Yeah,
right?
so an aerosol is just a word for a small thing, a solid or liquid that's so small it doesn't just sink right to the ground, but it is moved around by air currents. There's aerosol dust in this room, and so we're talking about increasing the amount of aerosol in the stratosphere is that one idea, and that could be done by aircraft flying in the stratosphere and releasing, say, sulfur dioxide, which turns into sulfuric acid aerosol.
Sulfur dioxide. Now, you've also considered the possibility of putting ground-up diamonds into the atmosphere, right?
Yep, that's obviously a little less plausible in the near term, but yes, that's another idea we've looked at, yeah.
But if you had, I mean, if you had enough of these, I don't know what the density of these diamonds would be, but isn't that going to interfere with any space program? I mean, you send up a rocket, and these little diamonds turn it into a needle very quickly.
No. You'd be actually talking about less aerosol density than there already is in the lower atmosphere. You're talking about small changes to the aerosol distribution. We already have a huge amount of aerosol in the lower atmosphere, which is making people sick from air pollution, killing them, and already reflecting some sunlight. We're talking about changes that would really be small. They would have like a 1% impact on the absorption of sunlight.
1%.
Yeah,
now
round numbers.
that's adequate to do what? Does that stabilize the warming?
Well, you only stabilize the warming if you stop putting the CO2 in the atmosphere. I'll keep saying that all interview. If you don't stop putting the CO2 in the atmosphere, you just keep getting more dangerous. But if you do that, and then in addition do some of the solar geoengineering, you can end up with substantially less risks. So what that 1% could do is it could reduce the actual number of people who die late in the century from extreme temperatures by a lot, like by half.
Okay, but you could argue, and some woman, in fact, there in the audience suggested, well, aren't we doing that already with contrails, right? Jet contrails are already putting, particulates in the atmosphere that clearly reflect a little bit of sunlight. They're white.
Well, yeah, contrails are complicated because they're actually thin clouds that can be heating clouds because they're high altitude, so it's actually a mixture of heating and cooling that's not so simple. But we are certainly putting aerosols in the atmosphere already in the form of pollution, and that is already cooling the climate. And that's one of the kind of traps that humanity's walked into, because if we ended all industrial emissions today, the aerosols that we put in the lower atmosphere last for about a week. So if we remove those, if we stopped all industrial emissions, those aerosols would go away in about a week. But the CO2 that we've been putting in lasts for, its climate footprint lasts for more than a millennia. And so if you stop suddenly, it actually gets warmer, not cooler, because the underlying warming from the CO2 is revealed because it's been partly masked by the aerosols.
So this is the kind of intervention that once started. You have to keep going, right? You can't just, after 2 years of doing it, we're going to stop that now.
Well, if you're starting it slowly, you could start it slowly, watch what was happening, and stop it for sure. If you've done it to a large extent, you wouldn't want to stop slowly. You don't have to keep it going forever, but you would not want to just suddenly stop. That's often called the termination shock if we suddenly stopped.
I'm talking to David Keith here at the American Association for the Advancement of Sciences in Seattle. This idea seems to be considered almost sacrilege by certain people in the in the community that's interested in climate change, which is a rather large community.
Yeah.
Why is that? I mean, do they feel sort of like, well, HIV might be caused by bad behavior. Consequently, we're not going to look for any cures. We just want you to stop the bad behavior.
I think the central region is this fear that's often called a moral hazard, that if we talk about this or if we begin to develop these technologies more seriously, it will lessen the political force to cut emissions. I think that's the reason a lot of people in the climate and environmental community are worried about discussing this.
What do you say to that?
I think I was one of the first people to say it. So I believe it's right that in the literature here, I was the first person to actually use moral hazard in this context. So I completely agree it's a concern, a very legitimate concern. I don't think the right answer is not to talk about it. So there were people in the 1970s who said we shouldn't put airbags in cars because it might encourage people to drive more dangerously. There were people who said we shouldn't allow the effective AIDS triple judge cocktail to be used in Africa because it could be misused and there'd be resistance built up. In hindsight, those both seem to be extraordinary or even kind of really racist and unethical things. I think the bottom line is that knowing about risk-reducing methods is important, and I think we have some ethical duty to understand those risk-reducing methods at the same time as we make clear to people that they need to also reduce the risky behavior.
Now, you're planning an experiment, a series of experiments, to test the consequences of at least putting the aerosols into the atmosphere, right?
We are doing experiments in laboratory and plan to do some field experiments to test some particular kind of narrow, nerdy scientific aspects of how, say, aerosols interact with each other in the stratosphere or how they interact with stratospheric chemistry. But this is not a test of whether solar geoengineering works or not.
Well,
it's certainly not a test of the climate response.
Well, what about the very obvious alternative approach? Forget the aerosols. They eventually, come back down. Why don't we just put something into orbit? I suggest you just put a bunch of mylar into the atmosphere and just in orbit high enough that it doesn't come down and just, block 1% of the incoming solar flux.
So this idea has been around for 20 years. In fact, there's early papers by a guy called Early. And as solar geoengineering got taken a little more seriously in the last decade, there's now more than 1,000 papers published in some real research. People in general kind of have completely ignored the space-based ideas and kind of, I think, effectively assume that they're just science fiction nuttiness. At the same time, as you know, there's been this huge improvement in cost of access to space and a sense of new development of space technology. So actually, we just, I think for the first time in decades, ran a really quite high-level meeting late last year, bringing those two communities together, bringing some of the kind of leaders of the new space technology world, some people from SpaceX. Pete Worden helped to organize that meeting, who's used to run NASA Ames and is very connected in that world, with some people from the solar geoengineering world, to kind of debate, is there any there? Does it make sense? What would be the consequences of thinking about it? I think the answer is in the near term, it's ridiculous. In the next decades, you're certainly not going to put things in orbit. But if you're talking about doing this over the century time scale, I think these ideas, not of low Earth orbit, which actually we agree just don't make sense, but the idea of a L1 shield in between the Earth and the Sun, I think are not, they're not obviously dismissible on the time scale of a century.
If you put it that far away, the Lagrange 1 point, then it would block, it would throw a shadow over quite a bit of the Earth, depending on how.
Very nicely over the whole Earth, and then what you see is a tiny dot in the Sun, which means it's continuous, it's not flickering, and it's not visible from the ground, and it's even. Anything you do in low Earth orbit is flickering, adds to orbital debris, and is uneven.
So you can't just put it over, just to name a place, Baffin Island, right, and protect that particular part of Canada. It would block the entire Earth, so it would be...
An L1 shield inherently does the whole Earth, yes.
I got to say, it would look like a dot against it. 1%, that would be the same as a transit of Venus. Maybe the thing to do is to orbit the, to
I
change
think it's
the
actually much more than a transit of Venus, but yeah.
No, 1% is about, I think.
Really?
Something like that.
That's cool.
Anyhow.
I have my own picture I took through binoculars of a transit of Venus.
Well, measure it out. Okay.
Yeah.
All right. We've been
Cool.
talking about blocking
Yeah.
sunlight. We've been talking about blocking sunlight, but what about other approaches to dealing with climate change, other than just trying to cut down the amount of sunlight? What else could we do that you would call geoengineering?
Well, I wouldn't really call anything else geoengineering, but I think that the things we do are...
Limits the discussion.
Well, what would you call geoengineering?
Well, I mean, there are plans, for example, to increase the growth of algae or carbon sequestration, something like that.
I would call most of those carbon removal technologies, it's often called now CDR, but I don't mind if you want to call it carbon geoengineering. What I would say is it's really distinctly different from what I talked about, in the sense that, to me, there are 4 big things we could do about climate: decarbonization for emissions cuts, carbon removal, solar geoengineering, and adaptation. And there's no way in which solar geoengineering and carbon removal are more like each other than they are like the other things. They're not more like for policy or for the technology or for the science. So I don't think they're 2 aspects of geoengineering in a meaningful way. And that's not just me. That's what the National Academy thinks. That's what IPCC thinks. That's become a kind of mainstream view.
If you had to bet on what's the, the most efficacious or cost-effective or some metric suggesting this is the better approach, what would you choose?
They simply do different things. You can't. It's like comparing babies to apples. They just don't do the same thing. So, carbon removal removes the long-term burden of carbon from the atmosphere, and solar geoengineering is a short-term kind of band-aid that reduces some of the risks. They're not substitutes for each other. They don't do the same thing.
Okay. Now, you've gotten, as I say, you've gotten some pushback on this, and yet you've continued to pursue this. And I believe you've said in various venues, you do that because, we shouldn't put our hand in the sand or whatever, and we should pay attention to this just to see whether, it has any value, whether it could work, and come back to it if we need to come back to it. I mean, what's your stance?
Well, my motivation is so I think people sometimes lose track of the fact that even if we cut emissions to zero tomorrow or in the next decade and a half, the danger from the CO2 in the air is there no matter what. So it's not either or. We actually need to think about how to reduce that danger, and that's real. A few weeks ago, I was in rural Bangladesh, in some of the poorest places in the world, talking with local people. These are in places that are most likely to be underwater in my lifetime. These are places where I talk with people who were lost relatives from the big cyclone in 2009. These are places that will be wiped out. And the reality is that that is true even if we ended emissions now. It's not a choice. And we need to, if there are technologies, and it looks like there might be, that could substantially reduce human suffering, real human suffering, and ecological damage this century, we should take them seriously. We need to understand better how well they would work, how we govern them, and how we can make them less risky. But I think, to me, my motivation is that. My motivation is trying to find ways to reduce that damage. And that damage is there even if we manage emissions.
You said that there's a very large slew of papers that have been published in this field. So you're not the only guy in this field, right?
No. These ideas are old. They started in the 1960s, long. The first report that had this in it went to President Johnson when I was 2 years old. And no, I'm one of the more visible researchers, but there's now lots of researchers. There's research programs in India, in Japan, a significant one in Australia. There's quite an effort at ETH Zurich. There's a Norwegian effort. There's many other efforts in the US. No, I think it's all still very small, but my view is we need a much more serious research effort, but it's definitely not a single person's thing.
Can you say fairly categorically, or maybe with great certainty, that anything we do, particularly in terms of putting some sort of reflectance in the atmosphere, cannot be restricted to a local effect? Is that true? I mean, you're going to have worldwide consequences, and that might be very complicated. I mean, it might be, the butterfly effect. You change things over here, and it turns out it does something terrible over there.
So you certainly could change the radiative forcing, the amount of reflection locally. So you could, with, say, this marine cloud brightening, make a local area that was a little more reflective. And that would certainly produce some local cooling. But that cooling can't be confined to one place. There's what we call teleconnections. If you push the climate in one place, it tends to pop out somewhere else, if you like. The world's all interconnected by flows of heat and momentum. If it was really true that each part of the climate could independently make its own climate choices with its own thermostat knob, then actually the governance problem would be easy. Everybody could just decide. But that's not true. It's fundamentally impossible. It's an interconnected world.
Well, they could decide for themselves, but they might also be able to decide for somebody else. I mean,
correct.
Carl Sagan made this point in connection with trying to deflect incoming asteroids, which is something you could, it doesn't violate physics to do that. It takes some money, but, the incentive might be high. But he said we should never develop that technology. At least he said that once. He said you shouldn't do it because then somebody, evil, like he used Saddam Hussein, but, is going to use that technology to make sure that the asteroid hits his enemies, kind of thing.
I think about that a lot, and I've written about that a fair amount. I think we want to, in developing these technologies, focus on technologies that are most difficult to divert to harm people. And so when I think about the different technologies, one of the things that I actually kind of like about the aerosols in the stratosphere is there's this slow 2-year time constant, and they all mix around the planet, so you actually can't localize it. So there really doesn't seem to be a way to kind of harm one place and not others. If you actually did make a system of low Earth orbiting reoriental mirrors, then you do have weather control and some ability to steer hurricanes and so on. I think, which is in a divided world, not a technology that you want to have. So my view is you absolutely should think about misuse of these technologies and choose most to work on technologies that are most likely to have global benefits, least likely to have local harms, and most difficult to misuse.
We're talking with David Keith. I'll get it right.
Yeah.
We're talking with David Keith here at the AAAS, American Association for the Advancement of Sciences meeting in Seattle. Could you do this from the ground? You know, a couple of years ago, I just took my camera outside. It has a light meter in it. I aimed it at some pavement in my neighborhood and measured the albedo, the amount of light reflected. And then I went to where there was a white line in the middle of the pavement. And I measured the reflectance there. And then back of the envelope calculation, if we banned macadam and made all our roads white, it turned out that the amount of extra energy reflected into space was, enough to keep Greenland from melting or something like that. So it was a lot. It was a lot. But of course, that's because 2% of the United States is paved.
Yeah.
But could we do this in the ground? I mean, could you, put silver glitter all over the Northwest Territories of Canada and maybe solve the problem without putting anything into the atmosphere?
So maybe you could. I've spent a fair amount of time in the Northwest Territories, and I love it. And I think if you put silver glitter over it, you'd have a huge environmental impact. And so from my point of view, I'd quit my day job and go rogue and try and be the eco-tager of your program. I think it's easy to think that something we do on the land surface is somehow less bad, but humans' biggest environmental footprint is the way we appropriate land from nature and manipulate it. So I think that of course, if you just manipulate land in a tidal area, you don't have any big harm, but you don't have any big benefit either. But if you actually want to do enough land surface to really change the climate, you have huge consequences. People talk casually about putting mylar foil over deserts, but deserts are things that some of us love and that have natural environments that we like to protect. At least from my point of view, I'm trying to do something that's environmentally protective. So I see those things as having very high environmental consequences per unit of benefit from what I've seen.
Let's ask the audience in case they have any questions, because we're running out of time here. Yes. Let me repeat the question, because maybe not everybody can hear. She's saying one of the things we talked about here is putting diamonds, small diamonds, into the atmosphere, and how would that affect astronomy?
Well, so first of all, whether it's diamonds or just calcite or sulfuric acid doesn't really make any difference, and the diamonds catch a lot of attention. It's nothing that's that serious, at least now. But we're only talking about blocking something like 1% of the sunlight at peak. And that does mean you block a little more than 1% of what we call a direct beam, so maybe a few percent. But it turns out that for optical astronomy, that would really be completely negligible, because optical astronomy is mostly limited by the photons we count coming from the sky. And it turns out that the noise goes as the square root of the number of photons. So blocking a few percent just doesn't change things meaningfully.
And the effect, by the way, on radio astronomy would be less. But I mean, if you want,
there may be near infrared effects. So we worried a little bit about near infrared, and I also think there's a problem of city light. So as you know, there's a problem of light pollution. And this is a paper we haven't published. We're going to work on. We're trying to think of bad effects of solar geoengineering. Light pollution spreads, from clouds, bounce the city light to distant areas. If you have effectively a very thin high cloud, but it's very high, you maybe make light pollution a little bit worse, all else equal. So there are definitely some effects, but the direct effect on optical band astronomy, I think we can say with confidence is tiny.
I mean, if you really want to save astronomy, then write Elon Musk, who's planning to put thousands and thousands of satellites up in orbit, and they are a real threat to astronomy. Yes, ma'am.
So I think if I want me to repeat the question,
Yes,
the idea here is that doesn't it necessarily mean if you have some partial technological fix that reduces the suffering that people will automatically kind of pull back on efforts to cut emissions? I think the answer is no. It may, but you can point to lots of historical analogs where the opposite happened. So commonly we solve problems. So the thing we're talking about is often called risk compensation. That if I provide you with some partially risk-reducing technology, maybe you'll have more risks. I do a lot of outdoor activities, and I'll take more risks if I have a satellite phone with me in the wilderness than if I don't. And I'll take more risk injuring myself because I know there's great medical care than if I don't. But so I think it's worth unpacking it. First of all, think about the auto example I gave earlier. So since I was a kid, we've had a factor of 5, roughly, decrease in auto fatalities per lane mile traveled. That's been a whole range of things, some of which were straight tech fixes, like airbags or better structures, some which were social. A lot of us are older. I'm older, and I used to drink more driving, and we just don't now. I think there's been a real social change. Some of it has been graduated licenses, other social changes. There's been a big range of reasons that we've driven risks down. And in some ways, they've been synergistic. The more we had a sense that we could drive risk down, the more motivation there was to keep doing it. And there are lots of examples like that. So you can think of tons of places where we have had some underlying risk-reducing technology, and we've had even more social activity to drive the risk further down because we had a sense that the thing was solvable. So I think it is a concern, but I don't think it's a reason not to. Let me finish. Let me flip this around. If you really were saying, I'm not saying you are, but some people are, that we shouldn't do this because effectively we need to see the climate suffering to make us cut emissions, which I know you're not saying, but some people come dangerously close to saying that. That is a deeply unethical thing to say, because flip it around. If it's really true that we want people to suffer, so we in the rich world are motivated to cut emissions, then it should be true we want people to suffer extra hard. We should actually deny them climate, local adaptation protections. The fact is there's a moral and political imperative to cut emissions, and that is more or less decoupled from what we do about adaptation or what we do about this.
Okay, we have about 1 more minute. I'm going to ask you one more question, and that's this. What about power sats? I mean, for the last 30 years, people have been saying, look, the way we should power our gusto-grabbing society is to put up, orbiting solar cell arrays, big stuff, right? And then beam the energy down on a microwave beam. You can be very low density, so you don't cook birds or anything like that. You have a bunch of antennas on the ground. You pick up the energy, you distribute it via wires. Nothing burns in the atmosphere, no burning whatsoever. It just gets you off of all of that right away. Why aren't we doing that? Is it impractical?
It's extremely expensive, and hard to see that it's that much better than terrestrial solar. So the most single important thing that's happened in the last 20 years in sort of climate in a way is the extraordinary decrease in the cost of solar power. So suddenly you can really build, 500 megawatt, gigawatt scale solar plants at well under $1 per watt installed capacity. It's stunning. That means in really sunny places, you're making some of the cheapest carbon-free power on the planet. And you could do the whole world on solar at only, less than 1% of global surface area. So I think the question is, why bother to put solar panels in this really expensive place when we can put solar panels on the ground? They get sunlight all the time, which is a factor of 3 benefit. Are you going to tell me that it's not a factor of 3 times more expensive? I took my name off one of the most highly cited papers I could have been on. My name was on that Marty Hoffert paper on pathways for technological thing, and I said, Marty, there already is a commercial market for space solar power for ComSats. And if you're going to tell me space solar power is cheaper, at least you have to put in that paper what the current cost is and provide some argument about why that's going to keep getting cheaper.
David Keith, thank you very much for being with us here at the AAAS meeting in Seattle, and I am sure you've enlightened the audience.
Thank you very much. Thanks a lot for the interview.